Load distance is a measurement of traffic, so to speak, within a layout. Therefore, load distance is helpful in developing a layout, although it's not a specific technique, and it's simultaneously a means of scoring layouts, and there it is an exact technique. Now, what do I mean by this? You can see this in the next scenario. RDRS is planning a new warehouse consisting of 8 equally sized spaces. So here's the layout of the building itself within the 10,000 square foot floor plan pictured below. Oh, all right, so their warehouse is basically long and skinny. RDRS has listed all 8 areas and noted the estimated weight of supplies that would travel among them. Oh, all right, so here's some data. Warehouse area, this is essentially what we're trying to locate up here in the warehouse. And this is information concerning the loads, so to speak. Right, load distance assumes that you want to minimize traffic. Now, if you're trying to minimize traffic, you first need some data on potential traffic. And you can see that for each of the 8 areas that's listed, there's some notes concerning how many supplies are exchanged in tons on a monthly basis between these areas. Oh, okay, so what's this say? How should they arrange the warehouse? Well, this first part is not an exact technique, but it's really just logic. All right, they've asked us to develop an arrangement for their warehouse. You know what I'm tempted to do? Let's look at the data, and I want to look for really large numbers. I notice, for instance, it says here for each of the high rack storage areas, they exchange 10 tons of supplies with each other, right? 30 tons of supplies monthly with, let's see, SA stands for staging area, but that is not the biggest number that I see here. I see a 50 here, a 50 here, and another reference to 50 tons of supplies. I'm just looking for the largest amount of traffic, because here the supplies moving in between the areas in the warehouse are the traffic. You say, all right, well, 50 is the biggest number I see. Then I ask myself, 50? Fine. What does that refer to? Well, let's see. Here it says tent storage, 50 tons with staging area, soft goods storage, 50 tons with SA for staging area, and up here, oh, that's actually referring to the same thing, because this is the line here for staging area, and it says 50 tons with tent storage and soft goods. What does this mean? It means that these two right here want to be neighbors with that area right there. So right away I'm tempted to say, oh, okay, well, let's see, I would want to put this in between them, right? So they could both be neighbors. So if I put the tent storage there and then put staging area here, I could put soft goods on the other side. That way, oh, they are neighbors, and that's good because lots of stuff passes between them. Now notice, I just made my first decision concerning the warehouse. Oh, all right. Now, what we basically need to do is to fill in the rest of that. How would you keep going? Well, another logical thing to do is we just took care of the areas with the highest amount of supplies moving between them, right? Maybe the next thing we should do is like the next highest amount of supplies. I noticed, for instance, the 30. Where does this 30 refer to? Here, 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 and here. Oh, okay, these high rack storage areas, each one of them exchanges 30 tons of supply with, this is staging area, staging area, staging area, and that's a reference down here on the staging areas line to the same thing. Now, wait, what's this mean? This means that each one of those high rack storage areas wants to be a neighbor with the staging area. And oops, I already decided who 2 of the neighbors of the staging area are based on 50 tons of supplies. There is, especially in this layout, the long skinny one, only room for 1 more neighbor left. Does that mean we've done something wrong? The other 2 want to be neighbors as well? No, we're just going to have to, right, we're just going to have to make some compromises. So for instance, we might put high rack 2 as one of the neighbors. Now wait, what about the rest of it? Actually, this is getting a little crowded. Let's move to the next note frame. If you have the note frame, is just the exact same layout with more room to work, because I figured out a layout for this particular scenario, and it did include, so let's just recopy now is all we're doing. Tent storage as being right here in the lower left hand corner, TN, and the staging area being right here. The soft goods storage, soft goods, right here. Just like I had just written on the page before, sure, I don't know, put the second high rack is what that stands for, area here. Now, the 3 high rack areas do exchange stuff with each other to a lesser extent, so it just sort of seemed logical to me. Well, why not line them up also? You could, for instance, do the assignment that way. We are left with only 2 slots open and only 2 more areas to locate. I look back at the original data and I say, oh, that's the administrative office and the tool crib. And as far as monthly relief supplies exchanged with other areas, it just says none, none. Oh, meaning it, at least with respect to traffic of supplies, doesn't really matter where they are. Okay, how about putting the admin office in back? Or AO for short. And then that just leaves for the tool crib, where we're storing all our tools that we use at the warehouse. Hit this right here. Okay, here we have a potential layout. Here we have a potential layout based on some of the sensibilities of load distance. Is this a good layout or a bad layout? Well, we don't have another layout yet to compare it to, but there is something that we can do that would make a definitive statement as to the quality of this particular layout. Now, having obtained this particular layout, you see how that was kind of trial and error, and you might have been working with the same data and not necessarily have put those departments in the same place that I did? Yes. This whole phase of the layout creation is inexact in that sense. This next step is not inexact, it is definitive. What is the so-called load distance score for this layout? It's like a grade. Is this a good layout or a bad layout? Well, I don't know. What is the so-called load distance score? All right, to calculate that, reading, what we need to do is go back to the original data and take a look at the load that is placed on some of these routes. For instance, in the original data, I did start with this 50, 50, and over here refers to the same thing. What was that? That was the fact that 50 tons move monthly between tent storage and the staging area, and 50 tons move monthly between the staging area and soft goods. I now want to note that. Okay, so I'm going to write a 50 here and a 50 here. That's what's moving back and forth in my layout now. Okay, now, that was just the 50s. What about the other information? Well, it says that 30 tons of supplies move in between each of the high rack areas and the staging area. This is just a restatement of that here. Okay, I want to plot that. This one's easy. Here is just back and forth. Supplies moving between the staging area and high rack 2. But we also have another 30 moving between here and here, and another 30 moving between here and here. And I know that you're looking at that and you're thinking, well, just draw a line, right? 30 and 30, don't do that. Don't do that. Don't draw a diagonal line. Here's something's interesting about load distance, the whole model. In load distance, when we are gauging traffic within a layout, we measure everything according to rectilinear distance. What does that mean? It means we assume we can't take the diagonal, right? That highly convenient route isn't actually a route that's open to us in a certain sense. No, if this is the staging area and we wanted to move something to high rack storage, we would not go that way. We go 1 over and 1 up. Okay, so the route is kind of elbow shaped like that. Although I can still note 30 from there to there, right? And the same thing here. There's another elbow-shaped route, if you will, that is 1 over, 1 up to connect the staging area with high rack 3. Oh, all right. There, we've got those on there. Now, what else? You say, oh, okay. There also were these minor routes. I mean, smaller numbers. What are these 10s? These 10s are supplies that are moving in between the high rack areas. For instance, from here to here, between high rack 1 and high rack 2, we know that there's 10 tons moving monthly. From here to here, 10 tons moving monthly. And actually, wait a minute, from here to here. Oh, so I could draw a route that's like all the way through, straight through here. I'm not going to do that only because I don't want to mess up the label. The supplies aren't going to leave the building, but I'm just doing this kind of like long, lazy rainbow sort of route, just to remind myself that there is 10 that's moving from here to here, and it probably is going right straight through here, right? I just didn't want to mark over that. Now, I'm reviewing the data, and I have added everything concerning the loads on all of the routes because there's no other numbers mentioned, which means there's no other routes to draw, so to speak. Oh, all right. Now I can tally the so-called load distance score, because here's what I do. These are essentially trips or routes, right? I'm going to write trip, meaning like you take a trip from, for instance, tent storage to the staging area. If you did that, or you're talking about those trips along that route, right? We said the load on the whole route itself is essentially 50 tons a month, correct? Now wait a minute, distance. I'm just doing an audit here of my work. Well, it's a distance. It isn't hardly any distance if you're talking about that 50. Right, it's a distance of 1, moving from here to here or from here to here. Oh, okay. Now, I'm going to put a check mark there to make sure that I know that I have actually already listed that one, because it looks similar to this one. From the staging area to soft goods is also 50. A trip distance of 1. They're right next door. We like that. Now, basically what I have to do is tally each of these. This one, this 30 right here, what is that? That is between the staging area and high rack 2. That 30 right there, and that's another nice short trip, a distance of 1. Let's see, what about from the staging area to high rack 1? From here to here, that's a load of 30 as well, right? 30 tons a month. But wait a minute, the distance is, remember, 1 over, 1 up, 1, 2. That's a distance of 2. Our elbow-shaped route. And likewise, going the other direction, the staging area to high rack 3 or back is still a monthly load of about 30 tons and a distance of 2. All right, that one's done, that one's done. The only ones that aren't on the list right now are the ones that I did in blue highlighter. Okay, I'll just add them. High rack 1 to high rack 2. Load of 10, their next door neighbor's distance of 1. Same as with high rack 2 to high rack 3, load of 10, their neighbor's distance of 1. High rack 1 to high rack 3, however, load of 10, but that's this one. It's 1, 2, a distance of 2. All right, so that one's there, that one's there, that one's there. All right, I have everything that I need to calculate load distance. Because load distance for any certain trip is nothing more than you take the load, you multiply it times the distance. We would say, for instance, in the case of the tent storage area and the staging area, under this current layout, the load distance is 50. 50 times 1. Same thing with the soft goods in the staging area. That's a load distance of 50. With the staging area in HR2 is a load distance of 30. 30 times 1. The staging area in high rack 1, 30 tons exchanged monthly, but the distance is 2, so we say that that represents a load distance of 30 times 2, or 60. And then very similar for the staging area in high rack 3. Down here, high rack 1, high rack 2, they're neighbors, so it's 10 times 1 equals 10. High rack 2 and high rack 3 are immediate neighbors, so it's 10 times 1 is 10. But high rack 1, high rack 3, from one end to the other of the high rack area is 10 times 2, or a load distance of 20. Why am I doing this? Because I want to add them all up. Load, distance, score. Meaning score for this layout that I just now made up, that we have illustrated at the top of the page. The total load distance score is 290. Okay, the layout, I just kind of made that up. You might make up a different layout, but the score you can't make up for any given layout. That's how you tally the load distances within the layout. Then you add them all up for a total load distance score. Oh, all right, we get 290. Is that good or bad? We don't have another layout yet to compare it to, but if we did, what are we looking for? Remember, in the case of load distance, the smaller scores are better. We wish we saw a small score. So we would be impressed with another layout, one other than mine, if by the time you tallied it up, it resulted in a load distance score that was less than 290.